Army policy says that practice touchdown auto rotations are to be conducted only during formal instruction at the Aviation Center, during rotary wing transition flight training courses approved by appropriate authority, during standardization evaluation flights, and when deemed necessary by the appropriate commander. Policy clearly requires that practice touchdown auto rotations are to be controlled by the local standardization board as an organized and closely supervised program. Survivability during what is training for an emergency goes up in direct proportion to the extent which those policy criteria are applied. Afternoon.
There's little doubt that for the instructor or standardization pilot, practice touchdown auto rotations can cause pressure. For this reason, Army policy says that consecutive one-hour auto rotation instruction periods should not be scheduled in any one day. Further, no more than 6 practice touchdown auto rotations per instructor, pilot, or student are to be performed during any one instructional period.
Policy also requires that training be conducted at a location that provides for a crash truck with crew standing by, air-ground communications, and a means for opening and closing the practice area. For night practice, specific training locations must be designated and equipped, and all minimum criteria must be observed. Policy also states that practice touchdown auto rotations may be carried out only in dual-control equipped aircraft, with a qualified instructor pilot and one set of controls who is current and proficient in practice touchdown auto rotations in the mission, design, and series aircraft being flown. Only the minimum required flight crew is to be on board the aircraft during practice touchdown auto rotation. Inasmuch as each aircraft has its own auto rotation characteristics, all entry speeds and altitudes during the maneuver are to be as specified in the flight training publication for the aircraft that is being flown. The flight parameters used in these publications have been selected to present the student pilot with a set of conditions which, if followed, will offer maximum potential for safe execution of the auto rotation maneuver under the monitoring and control of the instructor pilot. Policy expressly forbids unanticipated surprise practice touchdown auto rotation maneuvers, so the student can concentrate on acquiring the necessary knowledge and skills for this vital emergency procedure, free of that particular pressure. The standard practice touchdown auto rotation then starts from an altitude of about 700 feet above ground level, or as directed.
Okay, lined up on funnel.
Collective pull down, throttle to flight idle, cyclic and pedals adjusted for coordinated flight. The steady state phase. Minimum descent airspeed. Maintain steadily, normally, without variation. Maintaining constant ground track. RPM holding steady. Approaching the next phase. The deceleration phase. Nose up slightly. Rotor nearing normal to the flow. RPM increasing, but held below 339 RPM by small collective adjustments. Airspeed decreasing in the expected trade-off of RPM for airspeed, expending rotor inertia for lift. Cushioning the descent to the ground with very little forward airspeed.
You've got all those points straightened out now that we've been talking about, especially that bit about reducing the collective to break the ground run.
The problem in doing that, of course, would be that the rotors might flex and cause aircraft damage. The whole idea is to use collective to keep the aircraft light on the skids until run-out is completed to protect the landing gear. Elements of the standard touchdown auto rotation we've just seen are applicable also to field maneuvers, starting from different initial conditions, at low level, say. So long as the highest obstacle is cleared by 50 feet, Army policy says the low-level touchdown auto rotation can be performed at designated training locations, provided approach zones are sufficiently clear of obstructions to permit visual contact with the point of intended landing from auto rotation entry to termination. That entry speeds and altitudes are as specified in flight publications for the aircraft being flown. That auto rotations will be straight in, maintaining a constant ground track, and that speed reduction climbs or pop-ups will not be performed. As a practical matter, entry to auto rotation may occur almost simultaneously with the deceleration phase, if entry altitude is near 100 feet AGL. And from then on, the maneuver is identical with the standard touchdown auto rotation from higher altitudes. A standard touchdown auto rotation with a turn differs mainly in the initial conditions. And as pilots, you'll need to pay some attention to what's happening to the aircraft during the turns that precede entry into auto rotation. We're watching a maneuver that includes a 180-degree turn, but you're not limited to this provided other requirements are met. That you be straight in not less than 200 feet AGL, for example. If you'll remember, a while back we said that even if RPM is maintained, you'll experience a higher rate of descent during a turn due to increased G loading. Because of this effect, you'll have to initiate the maneuver at sufficient altitude and be sure to maintain coordinated flight to be in a steady state condition by that 200-foot AGL mark. Auto rotation then follows the pattern we've already described. Incidentally, while the flight training guides and other publications may call for minimum ground runs as the preferred termination, you shouldn't construe this as requiring precision touchdown or zero ground run auto rotations. The policy with respect to forced landing exercises is straightforward. The Army encourages you to practice these maneuvers, provided they are conducted only to an approved training area. But descent must be terminated and power recovery executed at no less than 200 feet above the highest obstacle. Practice hovering auto rotations are excluded from the minimum criteria we've been talking about. Except for instructor pilot training, policy says further that unanticipated surprise practice auto rotations from hovering are to be eliminated.
The tactic here, remember, is to hold what you've got, because the situation could be critical. Rotor energy has not been built up. Increased pitch could slow the rotor down abruptly, causing immediate loss of lift and a hard touchdown. Hold the collective pitch setting, allowing RPM and lift to decrease slowly, cushioning the landing with remaining rotor energy as in the case of the standard auto rotation by pulling collective slowly.
Of course, we've been talking about criteria and procedures in the training environment, and we haven't said a thing about what may be the most critical issue of all, surprise, and the crucial delay in pilot response it may cause. An engine can go at any time, under any operational condition, perhaps under something as straightforward as this mission involving 2 aircraft.
When you're in flight, survival may depend on split-second reaction and coordination. There won't be time for extended discussion about who's going to do what. All that has to be worked out in detail ahead of time, with a clear definition of which pilot will perform which duties, planned and accepted at the outset. Sort out individual responsibilities, pinpoint possible landing sites, do everything possible beforehand to cancel out the effects of surprise. Confusion in the cockpit can kill you, but not if you've thought the problem through and have trained yourself to deal with the unexpected, quickly, proficiently, effectively.
I'm having a pressure problem. Someone had to take it down.
That instinctive reaction, automatic, precise.
Oh, hell, there
collective full down, adjust cyclic for 80 knot attitude, adjust right pedal to counter loss of torque. May have saved them, for the pilot is ready for auto rotation entry if need be. A number of lives and an expensive aircraft, saved by prompt and knowledgeable response to an emergency that could have had disastrous consequences. Department of the Army policy accepts the conclusion that, as a minimum, current policies and procedures have been effective in Army aviation accident prevention efforts. My business is aviation safety. And a safe power-off landing like this one is the payoff for me. And it can be for you and everybody else who flies in Army aviation when your training for power-off landings takes the safe approach.
During a recent 2-year period, 33 Army personnel were killed by tail and main rotors while entering, leaving, or working around Army aircraft. It is of paramount importance that during your training, you learn, master, and at all times thereafter, follow the safe procedures for entering or leaving aircraft to protect yourselves from tail rotors and main rotors. The following rules must be observed for safe boarding of helicopters. First, be sure the helicopter has fully touched down. The pilot must be sure that the helicopter's rotor system is level. You must always use caution when approaching an aircraft, whether as a passenger, refueler, mechanic, or loader. You should approach a helicopter within range of the pilot's vision. That is, within an area 90 degrees right or left of the nose of the helicopter. Never go around the tail. Radio men must ensure the radio antenna they are carrying does not protrude upward in such a manner that it will come in contact with the rotor blades. Of course, if a fixed-wing aircraft is involved, and for any reason you have to go around it, you must go by way of the tail to avoid the plane's propeller. You must always keep in visual contact with the aircraft you are approaching. With the OH-6A or the OH-58, you have a special problem. After being sure the pilot has fully touched down, approach this helicopter with even more caution, if that is possible, because of the unusually low rotor blades. A combination of low rotor speed and high gusty wind increases the hazard to personnel in the immediate vicinity of the aircraft. When leaving the aircraft, the same rules apply as on entering, and be certain that all loose items have been secured. The dangers here are apparent. In loading and unloading internal cargo, the same rules for personnel safety apply. Always be alert and keep low. It is a safe habit to get into and keep. It can save your life. In the case of the CH-47, the pilot must be sure that the helicopter rotor system is level and the aircraft is fully touched down before loading troops or internal cargo. When loading or unloading personnel and/or portable cargo, the loading ramp should be approached only from the right or left of the helicopter's tail within a 45-degree fan area on either side of the aircraft. This is to avoid the excessive exhaust temperatures directly behind the aircraft. Under normal conditions, the CH-54 tail and main rotor blades present no problems in coming in contact with personnel on the ground. But remember, it is a helicopter, and precautions must be taken. You must always look out for blowing objects caught up by the rotor wash. In addition to tail rotor and main rotor blade hazards, armed helicopters, such as this Cobra AH-1G, present additional dangers through their weapons systems, and they should be approached with extreme caution. When operating in rough terrain and/or combat situations, you must give close attention to the aircraft commander's instructions for departing or entering the helicopter. In extreme conditions of terrain, where the helicopter cannot fully set down, close coordination must be maintained between crew and passengers to avoid dangerously low rotor blades. Passengers must be instructed how to exit the aircraft on the upslope side of the helicopter where the tail and main rotor blades are nearest the ground. The same precautions apply to any model of helicopter used in this kind of situation. When operating in an open terrain area, personnel must always be on guard for loose objects on the ground which may be blown around by the rotor wash. Rotor wash effects increase in proportion to the size and weight of an aircraft. These helicopters are directed in the refueling area by ground personnel who should be dressed in proper work uniforms, wearing eye goggles and leather gloves, sleeves rolled down and buttoned, and leather boots. Dress in this manner protects personnel from flying debris and any fuel spilled during the refueling operation. When the aircraft has been parked in its proper refueling position, you wait before refueling to ensure that the aircraft rotor system is level and until you receive your go-ahead signal. The aircraft should be maintained at full operating RPM to facilitate aircraft clearing the area in case of fire in an adjoining fuel point. The crew chief gets out, opens co-pilot and pilot doors, slides armor shield to rear to make it easier for crew to escape in case of fire. Passengers must get off the aircraft and move to a safe area. All crew members will have their visors lowered. After assuring there are no open flames or smoking in the area, the crew chief with fire extinguisher in hand supervises the refueling operation. The refueler grounds the aircraft and attaches the nozzle grounding cable. The crew chief checks for proper grounding. The refueler removes the fuel cap, places the nozzle fully into the filler port, and begins refueling. Once the closed circuit system is attached to the aircraft, the refueling is automatic. In case of an emergency departure, the nozzle will disconnect. This is a design feature of the closed circuit system. This system may also be used to refuel manually. The crew chief must be in a position where he can see both the pilot and refueler, so he can signal between them. After reaching the desired fuel load, as indicated by a signal relay from the pilot by the crew chief, the refueler stops the fuel flow. He removes the nozzle, replaces the filler cap, disconnects the nozzle and aircraft grounding cables, and returns the nozzle to its rack. The crew chief returns the fire extinguisher and readies the aircraft for flight. The passengers are reloaded. These procedures may vary due to the configuration of the aircraft and type refueling system used. Personnel working around the OH-6A must use extreme caution due to its extremely low rotor blades. In addition to the low rotor blade danger, there is always a possibility of fuel feedback during manual refueling as the explosive fuel is flowing into the fuel tank. With the UH-1C and the UH-1M series aircraft, extreme caution must be taken in manual refueling due to the location of the refueling port. The same is true of the AH-1G Cobra. The fueling port is higher than normal and located near the engine air intake. If the nozzle slips out of the fueling port, or if a surge of fuel flow causes spillage during manual refueling, it could go into the engine, causing excessive acceleration, possibly damaging the engine and the driven components or start a fire. The closed circuit system shown will eliminate all of these hazards. The closed circuit system should be used on all aircraft when possible. The CH-47 helicopter, while big and high, has front rotor blades to watch out for. In a high wind condition, all blades are dangerous to personnel because they can flex down lower than normal. But the front blades are more dangerous as they are the lower of the two rotors.